In one of my previous videos, I programmed an Arduino to play PC games with a retro video game controller. How well does it work? Well enough to earn both respect from Maddie Thorson and shame from Ninja Muffin 99. However, there is an issue. Every time I want to play a different game, I must reprogram the whole board. This is no bueno, but you know what is?
Secure Digital, officially abbreviated as SD, is a proprietary.
The idea is to load various key mappings for different games from an SD card and be able to cycle through them without reprogramming. Also package it nicely, using a board with a nicer form factor. Microcontrollers can communicate with peripherals in a number of different ways, and this project uses all of them. In short, there's I2C, SPI, and Digital I/O. What should you use? Whatever the person who designed the peripheral told you to use. I'm using a SparkFun Pro Micro, which is basically a Leonardo, but mini. In fact, the word mini not only describes its size, but also how finicky it can be at times. The Pro Micro, like all other boards, has tons of digital I/O pins, and certain ones are dedicated to SPI and I2C. This project uses a Super Nintendo controller, a micro SD card reader, and a character LCD display, each of which use their own separate communications protocols. In my other video, I said this. You can find resources for most video game controllers from before 2000. Just go to Google and search the controller you're using plus Arduino and you'll find something. I probably shouldn't have said it, because there wasn't one for the SNES controller, but that's okay because I made one. So how does it work? Digital I/O is just pins on the board, upon which you can either read or write ones and zeros. A 0 is 0 volts and a 1 is either 3.3 or 5 volts depending on the board. This distinction matters. Anyways, the obvious solution is to create a parallel bus in which every button has its own pin, except Nintendo in the early 90s was smart enough to realize that is dumb and inefficient since there is 12 of them. Instead, we can use a serial bus in which all buttons come in one at a time over a single pin. This approach only requires 3 pins: clock, data, and latch. The latch pin goes from low to high for a moment to signal the start of a transmission. Then the clock pin goes high, low, etc., etc. With every successive clock cycle, the data pin changes for the status of every respective button until all 12 of them come in. While this is happening, the board reads all these bits and stores them. Buttons are mapped to keyboard inputs, yada yada yada. Watch my other video, you I'm using an Adafruit micro SD card breakout board, and it interfaces with an Arduino using Serial Peripheral Interface, or SPI, because bit-banging digital I/O as I did with the controller is dumb and inefficient. An SPI connection has a main device and at least one sub-device, and there are 4 wires: clock, main in sub out, main out sub in, and chip select. All of these have their own dedicated pins and are shared between main and every sub, except for chip select, which is just any digital I/O pin used to select that specific device. Configs are stored in a text file, and you can cycle through them using push button. The keyboard library takes in ASCII characters, so it's simple as typing them in. However, not all keys respond to a character, so they are seemingly arbitrarily assigned to other bytes, which do in fact correspond to ASCII characters. However, Notepad does some weird things, such that when I paste them in, they just don't work because it changes the encoding, so I just have to use a hex editor or something else. Nonetheless, all that happens to happen next is taking out the SD card and putting it in. That's cool, but how can you tell what you're doing? That's where the display comes in. This is a 16:2 character display, and it can just display whichever configuration is being used. This is a driver board because it is controlled by some complex bus that I cannot be bothered to set up, but I can be bothered to use an I2C interface. Inter-integrated circuit, or I2C, is a more rudimentary serial interface that only has 2 wires, serial clock and serial data. Once that is done, just code the thing, upload the thing, realize you bought the wrong display. Wait a minute. This is a logic level converter, because I did a goof by buying a 5-volt display and a 3.3-volt microcontroller, and those things can't talk to each other. Fortunately, I am powering this board over USB, which provides 5 volts that the logic level converter can tap into. Now all that is left to do is load some mappings on the SD card and play Tetris with the components on perf board so that I can solder it into a more permanent package. And that's it, I suppose. It's done. Take a look. So yeah, thanks for watching. The Super Nintendo controller library and my Arduino sketch will be linked in the description, and I'll see you whenever I feel like uploading again. Oh boy, I'm bad at this game, which is why I'm gonna choose hard. Am I actually gonna win this? Whoop, there it is.